Open your books to page 379. We are in lesson 25.3, still multiplying polynomials. So again, we're going to use the box method to multiply polynomials, and we're also going to use the distributive property to multiply polynomials. And you also need that note packet that we've been filling out as well. So the box method can be used to multiply when we have more than two terms. So thus far, we were just doing a binomial times a binomial, a 2 by 2. But sometimes we can have a binomial times a trinomial. And so if you see the box method to the right, they're showing us x plus 2 being multiplied by x squared plus 2x plus 3. Okay, so they put their x and 2 on the top and x squared, 2x, and 3 on the side. So this is a 2 by 3, so we have 6 total boxes. Now, if you wanted to, you could actually turn your box the other direction so you have your 2 terms here and your 3 terms on top. Either way works, okay? Maybe you're going to choose what way works for you depending on how much room you have on your paper, etc. Whatever you prefer. Then, after we do that, we need to combine our like terms. And again, remember our like terms occur on our diagonals. So I have an x cubed, and I have nothing that's like with that. But here I have 2x squared and 2x squared. Those are like terms on the diagonals. And then I also have 3x and 4x. So notice when we combine those, we get x cubed plus 4x squared plus 7x plus 6. Okay, so for question 1, draw the box method in the My Notes section of your book, because under question 1 they don't give you room. So the directions say use the My Notes section of your book. So you can draw your box however you prefer. I am going to do mine just like the book did, just to provide you with some consistency. So x minus 3, x squared, 5x, and 6. Now, I want you to go and multiply these and fill in each box here. You can do it. So I'm multiplying the tops and the sides, and then these are my like terms for my x squared that I need to combine together, and these are my x's that are like terms. So for standard form, I'm going to write my x cubed first. 5 minus 3 is 2x squared. 6 minus 15 is negative 9. And then minus 18. So now I have 4 terms here in my answer. How many boxes would you need to represent the multiplication of these 2 sets of parentheses right here? So under question 2, how many boxes? Under letter A, explain how you found your answer. Under question B, would you use the box method for multiplying with this many terms? Yes or no, and explain. So pause the video and answer all of question 2. This first set of parentheses has 4 terms. The second one has 5, and so it's a total of 20. How did I get that? I multiplied the number of terms in both polynomials. So that would be question A. I multiplied 4 times 5, which is the number of polynomials. And would I continue to use the graphic organizer to multiply with this many terms? I would say no, because my boxes, there's going to be 20 of them, there's going to be a lot of them, it's going to be very large and take up a lot of space on my paper. So again, we've already talked about the distributive property, but the book brings it up again. It is used to multiply any polynomial by another. And so what we do is we take this first term and multiply it by each term in the second one. Okay. And then again, we would take the second term, -3, and we would multiply it by each term in the second set of parentheses. We would get 6 total terms, and then when we combine them, we end up with 4. They didn't show you every step there. But you know how to do 3a and 3b. So you can use the box method or you can distribute. Pause the video, do 3a and 3b. X times x is x squared. X times 5 is 5x, and we can leave our answer like that. Letter B, some of you might have used the box method. Some of you might have thought about FOIL first, outside, inside, last. Combine my two terms in the middle. So we get x squared plus 3x minus 18. Okay, for C and D, we can use the box method or we can distribute, whatever you prefer. So let's do one of each. So I'm going to draw my boxes here. If you don't have enough room, you can use the My Notes section of your book. 2 by 3. I also could have done it horizontally the other way. So 3x squared times x is 3x cubed. 3x squared times 7. X times negative x. Negative x times 7. Negative 1 times x. Negative 1 times 7. And then we have these terms that we're going to combine together. Oops, did it up. And those terms, and remember if there's not a coefficient, it's a 1 out in front. So I have 3x cubed, 21 minus 1, negative 1 minus 7, and then the constant term of negative 7 goes at the end. Letter D, for the distributive property, again, use the My Notes section of your book if you don't have enough room. We're going to take 3x and distribute it to each term in the second set of parentheses. So it's 3x times 4x squared, 3x times 4x, 3x times negative 3. And then we need to do the exact same thing with negative 7. We need to take that and distribute that to each term in the second set of parentheses. So negative 7 times 4x squared, negative 7 times 4x. Negative 7 times negative 3. And now we need to combine our like terms. So I have a 12x cubed, and I don't have any other x cubes. So that's done. And then we have 12x squared minus 28x squared. So that would be negative 16x squared. And these are gone. And then I have a negative 9x minus 28x, which gives me negative 37x. And these are both gone. And then I have a positive 21. So one way to check your process to see if you're doing that right when you're distributing is, remember, we need to have 6 terms to start because it's 2 by 3, 2 times 3. And that was the answer to question 4. How can you predict the number of terms? Well, we multiply the product. We multiply the number of each terms in our parentheses, in our polynomials, and that's only before we combine like terms. Because here we ended up with 4 and 4. We're going to skip these questions, and we're going to go to our note sheet, or our note packet. We cannot think about foiling for these because they're not both binomials. Okay, so you can choose either to use the distributive property or the box method. Distributive property or the box method. So if I'm using the distributive property, take 2x and distribute it to x squared. So it'd be 2x cubed. 2x times negative 5x is negative 10x squared. 2x times 4 is 8x. Then we're going to do the exact same thing here with the negative 5. So 2x is done. Now it's negative 5's turn to be multiplied or distributed to everything. So it's negative 5x squared. Negative times a negative is a positive 25x. Negative 5 times 4 is a negative 20. So my 2x cubed, I'm going to leave that by itself because I can't combine it with anything. And then if I'm looking, I have negative 10x squared, negative 5x squared. So add those together and we get negative 15x squared. Then I have a positive 8x and a positive 25x. Add those together, we get 33x. And then lastly, I have a negative 20 with nothing to combine it with. And get in the habit of boxing in or circling your final answer so I can find it. And then I want you to try the box method on your own, so go ahead and pause and take the time to do that. You could have drawn yours horizontally and done a 2 by 3 instead of a 3 by 2. Either way, we should still all get the same answer. Negative 10x squared. Oops, I already made a mistake. 5x squared, I got ahead of myself, positive 25x, positive 8x, negative 20. And then our diagonals here are our like terms. Those are what we're going to combine together. And we actually end up getting the same answer because this was the same question. Plus 8, 25 makes 33, minus 20. So you get to decide, again, for these types of questions when we have a 2 by 3, if you want to use the box method or the distributive property. It's your choice.